Okay guys, well welcome to today's video. Today we're looking at trigonometry, or the early part of trigonometry at least. And in trigonometry we have this saying, and the saying is so car toa. And I like to remember this saying by using the jingle from an ancient, all the way back in the year 2002, this ancient commercial for tasty rice cracker brand known as Succotash, and here's the ad. And so I like to remember the Trig saying as so katoa. But what does that actually mean? So katoa, right? Well, so, S for sine theta is equal to opposite over hypotenuse. C for car, or C for cos, I should say, ca, which is JFK's favorite trigonometric ratio, is going to be cos theta is equal to adjacent over hypotenuse. And then finally we've got TOA, which is tan theta is equal to opposite over adjacent. Okay, and now understanding our trigonometric ratios, let's move on to the types of question you're going to get in year 9 and also early parts of year 10. Well, we have this triangle here, and there are 3 different types of trig questions that you're going to get. And the first type that we have, well, with respect to the angle, what 2 sides do we have? Well, with respect to the angle, we have the opposite. We also have the hypotenuse, right? So that is going to be a so, right? Because we have opposite and hypotenuse. So therefore we would use sine 69.
Nice.
Equal to opposite, which in this case is x, over
21.
And the reason that this is a type 1 trig question is because, well, we have the unknown on the top here, yeah? And for a type 1 trig question, in order to get the unknown by itself, all we do is we times by the denominator, which in this case is 9 plus 10.
21.
So then x is going to be equal to 21 sine 69. And then we would put that on the calculator. Put that in the calculator, I should say. And 21, or 9 plus 10 sine 69.
Nice.
Is going to be, to 2 decimal places, 19.61. Right, so that is a type 1 question. We simply multiply by the denominator to get the unknown there. So now moving on to type 2 trig questions, right? And type 2 trig questions, well, with respect to the angle, we have both the adjacent and also the hypotenuse. Okay, so that means that we've got a ca scenario, right? And so that means we would go cos of 69.
Nice.
Is equal to 9 plus 10
21.
over our unknown, which is x. And the reason this is a type 2 question, well, we have our unknown on the bottom. So normally, if we were to do full working, right, what we would do is we would times both sides by x and get x cos 69
Nice.
is equal to
21.
or 9 plus 10, as the cool kids say. And then we would divide both sides by cos 69.
Nice.
And we would get x equals 21 over cos 69 there. And then you would put that into the calculator. However, this is a lot of working, all of this, isn't it? Right, it's a whole 3 lines, and as mathematicians, we are somewhat lazy people. So what we can do instead is, because every mathematician who is worth their salt knows that we have to times and then divide, what we do is we simply put in this, well, I'll rewrite it here. We've got cos 69
Nice.
is equal to
21.
9 plus 10 over x. What we would do is we put in this double arrow system here. By putting in that double arrow symbol, what we're going to get is we're going to get x is equal to 9 plus 10 over cos 69.
Nice.
And, well, I refer to this double arrow as a switcheroo, Yeah, because it then gives you the nice little rhyme. Type 2 trig question, right? Type 2 the old switcheroo. So we simply swap the cos 69 or whatever our trig function is with our unknown, and we get x is equal to 21 over the cos 69 there, and then we put that into the calculator.
21
over cos 69.
Nice.
And we get to 2 decimal places. We get 58 point, well, to 2 decimal places, it would be 60 because it rounds up there. So type 2, the old switcheroo. Okay, moving on to type 3 trigonometry questions. Well, in type 3, well, the unknown for the top one, for the first type is on the top, and then it's on the bottom for the second one. And then for the third one, the unknown is the angle itself. So we use the Greek letter of theta or theta there, yeah? And so, with respect to the angle, we have the opposite, which in this case is 9 plus 10.
21
And we also have the adjacent, which is 69. And so, well, in this case, we would have a TOA, or tan theta, right, because we don't know what the angle is equal to opposite over adjacent, 9 plus 10 over 69.
Nice.
Righto. So then, well, in order to get the angle by itself, we have to undo our tan function. And the way that we undo a tan function is we basically do an inverse function. So you'll notice on your calculator there maybe that there is a sine to the -1, cos to the -1, and tan to the -1. They undo their respective functions. And so in this case, we're going to do tan inverse, right? On both sides. Some people call it arctan or arcsine or arccos, because you could think about it as their arch or arc enemy. Right? So then we would have theta is equal to, well, it would be tan inverse of
21
over 69.
Nice.
And when we put that into the calculator there, well, let's do that now. Tan inverse 21 over 69. We are then going to get, well, we would get 16.93 to 2 decimal places there. And because this is an angle, of course, we have to remember to put in degrees symbol for our units. And so just to reiterate, type 1, the unknown's on the top, so we simply times by the denominator. Type 2, well, type 2, we do the old switcheroo, the unknown is on the bottom. Type 3, solving for the angle, we use an inverse trig function to get our angle there. So hopefully this helps, and this is the end of the video. Bye.